The ionic compound formula consists of positively charged ions and negatively charged ions to give a total of 0 charges for the whole compound. For example, calcium chloride, the +2 on the calcium indicates that calcium ion carries 2 positive charges. These 2 positive charges comes from the calcium atom that loses 2 electrons when forming an ionic compound. Calcium has 20 electrons, 2 of them in the K shell, 8 of them in the L shell, 8 in M, and 2 in N shell. When forming the ionic bond, the calcium loses the 2 electrons in the N shell. The other part is the negative chloride ions with 1 negative charge. The chlorine atom has 17 electrons, 2 in K shell, 8 in L shell, and 7 in M shell. During the formation of the ionic bond, chlorine atom gains 1 electron and becomes chloride ion with a -1 charge because it gains 1 electron, which makes the number of electrons larger than the number of protons by 1. If you look at the total charges, it is equal to the +2 for the calcium ion plus the 2 chloride ions. Each of them has 1 negative charge is equal to 0. So the total charge for ionic compounds is equal to 0. We know that each calcium ion needs 2 chloride ions for the ionic compound to have a total of 0 charges. You can see that we can use the electronic configuration to deduce the ionic formula of ionic compounds. Here are some of the elements in the periodic table and their charges. You can see that all elements in the first group has 1 positive charge. They tend to lose 1 electron during the formation of the ionic bond. And the second group, each element has 2 positive charges. They tend to lose 2 electrons during the formation of the ionic bond. If we looked at group 7, the halides, each one of them carries 1 negative charge because they tend to gain 1 electron during the formation of the ionic bond. For transition elements, they tend to lose electrons from s, then d orbitals successfully. So they have more than 1 positive ion. For example, iron 2+ and iron 3+, and chromium 3+ and chromium 6+. Some ions contain more than 1 type of atoms. For example, ammonium ion NH4+, or carbonate ion CO3 -2. We call them compound ions. The plus on the ammonia and the 2- on the carbonate are called formal charges. Balancing the ionic compounds tells us the formula of the ionic compounds. Let's solve this example. Write down the formula of the following compounds: magnesium nitrate, calcium sulfate. First, magnesium nitrate. Magnesium forms positive cation. The magnesium atom has 12 electrons, 2 in K shell, 8 in L shell, and 2 in M shell. It loses 2 electrons from the M shell when forming the ionic bond to reach the stable configuration, forming the magnesium cation Mg2+. Nitrate NO3 has 1 negative charge. In order for nitrate to form the ionic bond with magnesium, we need 2 nitrate ions. The magnesium nitrate forms due to the ionic bond between 1 magnesium ion plus 2 nitrate ions. The compound formula is MgNO3/2. Notice we write the nitrate formula between 2 braces, and we add 2 as a subscript to indicate that we have 2 nitrate ions. Second, calcium sulfate. Calcium forms a positive cation with 2 positive charges as we saw before, and sulfate SO4 has 2 negative charges. The compound formula is CeSO4. Let's try to solve this exercise. Name each of the following compounds: Na3PO4, NH4/2, SO4, AlCl3, CaNO3/2. First, Na3PO4. Na stands for sodium and PO4 phosphate. In A, we have 3 atoms, so triasodium and the other part, PO4, is phosphate. So the name of the compound is triisodium phosphate. NH4 by 2, SO4. NH4 is ammonium and SO4 is sulfate, so the compound name is ammonium sulfate. Al, Cl3, aluminum trichloride. Notice here we wrote tri before the chloride to indicate that we have 3 anions. CaNO3 by 2, the name is calcium nitrate.